We're all pretty used to smart devices in our pockets and homes. But what about a smart factory? They're powered by something totally invisible, a massive, constant stream of data. So today, we're going to pull back the curtain on this unseen journey, from a single tiny sensor to a decision that can save millions of dollars. All right, so here's our game plan. We'll start by looking at the factory's nervous system. Then we'll meet the different members of the data family. After that, we're going to follow a single data point on its wild journey, look at the very real obstacles it faces, and finally wrap up with why all of this matters so much. Okay, first things first. We throw around this term smart factory all the time. But what does that even mean? What's the secret sauce? I mean, is it just about having cool robots and automated assembly lines? Or is there something deeper at play, something that you can't actually see with your own eyes? Well, here's the answer. The real magic is an invisible nervous system. Think about it. Every machine, every process, every single corner of that building is constantly sending out signals. And it's this nonstop flow of information that lets the whole operation think, react, and even learn on its own. So, if the factory has a nervous system, what are the signals running through it? To understand that, let's meet the data family. It's a great way to think about it because each member has a really specific and totally crucial job to do. And this table just lays it all out perfectly. First up, you've got process data. Think of these as the factory's vital signs, like temperature and pressure, keeping things running second by second. Then you've got machine data, the vibrations, the motor speeds, that basically tell you how a piece of equipment is feeling. Production data tracks the big picture stuff, like how much you're making and if it's any good. And finally, there's environmental data, like air quality or even the weather, which helps manage risks from the outside world. Each one tells a totally different piece of the story. So we've met the whole family. But how does a single reading, let's say one vibration measurement from one motor, actually become something useful? Let's follow that single data point on its journey, all the way from creation to consumption. And here it is, the 5 essential stages of its life. It all starts at the sensor. Then it gets captured by a local system. And then, and this part is so important, it gets preprocessed. That just means it's cleaned up and double-checked for errors before it gets stored away. Only then is it finally ready to be used to power some analysis or trigger an automated decision. Every single data point goes through this. Let's dig into that preprocessing step for a second, because you could argue it's the most important one of all. This is the quality control checkpoint. If you skip this, you get the classic garbage in, garbage out problem. And a smart factory that's making decisions based on bad data? Well, it's not smart. It's just really fast at being wrong. But what's really amazing is how resilient these systems can be. You know, what if a sensor just fails and the data disappears? It's not necessarily game over. There are incredibly advanced models that can look at data from nearby sensors and historical patterns to intelligently fill in the blanks. They can literally reconstruct the missing data and keep the whole operation from grinding to a halt. Now, this all sounds great on a whiteboard, doesn't it? But the factory floor is not some clean, quiet, perfect laboratory. The journey for our little data point is absolutely full of real-world challenges. This right here is what engineers call the laboratory to factory gap. In a lab, everything works perfectly. You've got perfect conditions, perfectly calibrated gear, but on the factory floor? Oh man, it is harsh. It's noisy, there are vibrations, and Wi-Fi signals can be unreliable. What works perfectly on paper often falls apart in the real world. And when you really get down to it, the list of specific problems is long. Sensors just lose their accuracy over time. Data packets just get dropped and disappear. Signals from 2 different machines might arrive out of sync, and you might have a brand new high-tech sensor trying to talk to a control system that's 30 years old. It is a messy, complicated environment. This quote from the source material just hits the nail on the head. Protocol mismatch and semantic heterogeneity. Sounds super technical, right? All it really means is you have different machines that don't just speak different languages, they have completely different ways of describing the world. Trying to get them to talk to each other is a massive challenge. So after hearing about this tough journey and all these challenges, you might be thinking, why bother? Why go through all this trouble? Well, it's because the payoff is absolutely transformative. This is the so what. This is why it all matters. When you get the data right, you can do incredible things. You can predict when a machine is about to fail and fix it before it breaks, saving a fortune in downtime. You can build systems that actually learn and optimize themselves over time. You can trace a tiny product defect all the way back to its root cause in seconds, not days. This is where all that data turns into real, tangible value. So when you step back and look at the big picture, this whole complicated journey from a tiny, unseen sensor through all the digital cleaning and processing, past all those obstacles, that whole thing is the very engine of modern manufacturing. It's what turns a big collection of dumb machines into a single, intelligent organism. And that kind of leaves us with one last thought to chew on. If all this data really is the factory's brain, constantly learning and adapting, what are the consequences when faulty, unclean data teaches that brain the wrong lessons? It really puts into perspective just how high the stakes are.